Alright, gang, this is our last lecture before the next exam, so we're going to kind of finish up climatology here. And I figured it'd be good to learn a little bit about Arizona in particular, what our climate like is here. So here we go. So there's a number of things that help determine climate. You got insolation, that's the amount of sunlight you're going to get from the sun. Temperature, which obviously correlates to that to some degree. Air pressure, high or low, wind belts, air masses, and precipitation. But if you notice, I've highlighted temperature and precipitation because those are the two I'm going to focus on for Phoenix. What controls temperature? We already talked about a little bit, so this is a bit of a review. But you have latitude and continentality. Right, with latitude, the closer you are to the equator, your temperatures are more or less constant throughout the year. You don't have seasons, and then as you approach the poles, you get bigger swings between summer and winter, and so you get a lot more seasonality. For Phoenix, we're kind of here with Louisiana, but obviously we get quite a bit hotter than that, and cool off to about the same. But that's kind of what we look like. Continentality we already covered, but it's the idea that if you live near ocean, you're going to be cooler because you have transparency. Sunlight penetrates deep into the water. The water evaporates, absorbing latent heat. It can convect, rotate around. As you're in the continent away from oceans, you get more extremes in temperature because the land has less evaporation. You're not going to have convection. Land has a lower specific heat than water. So that's why you'd rather live in San Diego than Wichita, Kansas. Here in Phoenix, we obviously have a continental climate. We get very hot, and we can get to freezing or below freezing. Alright, so our climate conditions. The big ones are, and I would write these down, we get monsoons. That's what generates our summer rain. There's our classic haboob. That dust front that you get from the downdraft of a thunderstorm. It hits all the dust and kicks it out. Then you get winter rain, which is frontal systems. This is all the snow over Arizona. This is Grand Canyon, by the way. And this snow is dumped by a frontal system in the wintertime. We don't get snow as much, but this would produce rain for us in the winter. And we're hot. So for Arizona, we got monsoon summer rain, frontal winter rain, and we are hot. Okay, so what are summer monsoons? Technically, monsoon means a change in the winds. And for us here, it means we're shifting. Typically, we're in the westerlies, but when they shift, we get winds out of the east. So we get easterlies, and that's when we're in monsoons. And the key is a high pressure out in the Atlantic moves westward, and that starts driving winds off the Gulf of Mexico and the Gulf of California into Arizona. And that's what provides us our moisture. So here's a cool diagram that shows this. Here's the Azores Bermuda High. It moves inland because of the way it spins, right? Winds go out and turn to the right, so it spins this way, and it drags moist air from the Gulf of Mexico and California up into Arizona, and the winds are out of the southeast or east instead of being out of the west. Then we're in monsoons. Technically, they will say we have started our monsoon when we have 3 days in a row with dew points 55 degrees or higher. Remember, that's the point at which you reach 100% relative humidity. Moisture comes from the Gulf of Mexico and Gulf of California. The lifting mechanisms, you have to lift the air to cool it off. And the three are convection, orographic, and downdraft. And that's because you need to lift the air in order to cool it off and generate rain. So I'm going to go over the lifting mechanisms. Convection. Sorry, that I kind of went into a different world there for a second. Convection is just where you get the warm air down below. It gets so hot that boom, it lifts. It reaches 100% relative humidity, starts pumping out latent heat, stays very unstable, and boom, you get a nice thunderstorm. Okay, that's the classic. But remember, this only happens if the air up here is colder than the air as it cools off and rises up. But if this air is warm, this air will have a really hard time lifting off. So this can be tougher than what you think it could be for Phoenix. Okay, orographic. we covered this, but obviously as winds blow from left to right, in this picture, you're getting a bunch of rainfall along this mountain range here in the U.S. You can see all the green and how dry it here is on the other side, right? It's forced to go up and over. That happens to a smaller scale. In Phoenix with our small little mountains, you kind of think of our mountains here in Phoenix like little skateboard ramps, and the winds hit it and just goes poof, and it skips off our mountains. And sometimes that's just enough to kick off a thunderstorm. This is just a cool picture of Mount Fuji with an awesome cloud over it as the wind goes up and over it. Okay, downdraft. So this is cool too. So far we've done two, right? We have the warm moist air can lift through convection. It can skip off the mountains like a skateboard jump, but also remember with thunderstorms they have powerful downdrafts where cold air rushes down, and that's what brings the rain down. Well, that cold air can act like a mini cold front and force warm moist air aloft, and it can basically cause a, I guess, positive feedback where one storm builds up, it dies, kicks off its downdraft, which then kicks off another storm, which then kicks off another storm, and then they kind of build and spread out from just that initial one storm. So sometimes, like the Weather Center will say, like, look, man, you got a 50% chance of rain, and then it doesn't rain at all, and that's because you never had that initial either convection or skateboard kick off a mountain to get that one storm. But once you have the one, it's a lot easier to get a bunch more storms from the cold air that pours out of the thunderstorm that can force the warm moist air aloft elsewhere. Anyway, super cool. Winter frontal system. So that's why we get rain in the wintertime. I kind of already covered this. But the general idea is that to the south we have warm moist air. To the north we're cold and dry. Low pressures from the jet stream spin counterclockwise, and this forces warm moist air over cold dry air, causing storms. So here's the warm moist air, cold dry air to the north, and then we're back to this diagram again, but we just pretend this is Phoenix, right? This cold front would have just passed Phoenix, right? The warm moist air that's heading this way gets sideswiped by the cold dry air that's spinning around this low pressure like that. It's spinning around and it smacks into the warm moist air, and you get storms right along here. That's what generates our, that's why we get rain in the wintertime with frontal systems. There's the sidelong look at it. Here's a cool frontal system, cold front heading right towards Phoenix, Arizona. Remember, it's spinning this way, so we're pulling in warm moist air off the Pacific. That's going to generate rain. All right, and then lastly, why is Phoenix hot? Well, we sit in the subtropical high. So here's the equator. Remember, that's where you have the ITCZ airs lifting like crazy, and you have tons of storms around here. But then a lot of that air, remember, dives down away from the equator at our subtropical highs, and we sit right at that subtropical high. So we have a dominant high pressure from the subtropical high. Also, you tend to have big high pressures out over the ocean because they're cold, and air likes to fall into things that are cold. And westerlies can drag that high pressure over onto us. We have a continental climate. We're away from the coast. And we're not on the equator, but we're relatively close, and that means we get a lot of sunlight. We get a lot of insolation, and that makes us hot. So here's what our climate graph looks like. We live in a desert. See, we don't get very much rain, but the rain we do, we kind of have some seasons. We have July, August, September. That's our monsoons. And then October, November, December, January, February, March, this is we start getting our frontal systems. Then you can see April, May, and June. The frontal systems have died off, and monsoons haven't kicked in yet. So June is actually the driest month. Our temperatures range from 100 down to about 55, and that's averages between day and night. Cool. So here's your things to know. The two major components of climate, temperature and precipitation. When does the Arizona monsoon start? Where does the AZ monsoon moisture come from and why? Which three lifting mechanisms impact the Arizona monsoon and how they work? And Arizona receives rain from frontal systems in the winter. You just need to know that. And you should understand frontal systems from what I've covered in a previous lecture. All right, guys, thanks so much. Have a good one.